Assalamualaikum. My name is Namofika binti Muhammad. I'm here to explain the structure of Linux-based operating system. Here is the structure of Linux. We can see here the standard library of utilities, applications, standard library of procedures, kernel, device driver, hardware. First, I will explain the hardware. This is the physical equipment of which your computer is composed. This includes things like your keyboard and mouse, your video card and monitor. Second, kernel. The Linux kernel reacts as the interface between the hardware and the operating system. Standard library of procedure. This is the Linux-based operating system will allow the user of software to communicate with the kernel. And the fourth, standard utilities and user application. A Linux-based system will come with a set of standard units like utilities, where these are usually simple commands that used in the operating system. This is the process flow. When a user runs a standard utility or applications, that software makes a call to the kernel via the standard library of procedures, requesting system resource such as the content of files or the input being fed in via the keyboard. The kernel in turn then queries the actual hardware for this information and then returns it again via the standard library of the procedures layer. This layering is what provides the system with a level of stability. If your application crashes for some reason, it is separated enough from the kernel to prevent it taking down the whole system. Now, I will explain the Windows architecture diagram. This is the diagram of the architecture Windows. This structure is known as a modular structure that composed of several simple modules. The modules are hardware abstraction layer, kernel microkernel, executive service, environment subsystem, integral subsystem. Protected mode or kernel mode. In kernel mode, the executing code has a complete and unrestricted access to the underlying hardware. It can execute any of the CPU's instructions and the reference of any memory addresses. The protected mode, or also known as the kernel mode, is commonly reserved for the lowest level and most trusted functions of the operating system. Crash in kernel mode are catastrophic since they will harm the entire device. And now we look to user mode. In the user mode, the executing code has no ability to access the hardware directly or the reference memory. The code that are running in the user mode must delegate to system APIs in order to access the hardware and memory. Due to the protections afforded by these isolations, crash in user mode will always be recovered. Most of the code that are running in the computer will be executed in the user mode. Now we look for the kernel. Kernel is the core feature of any operating system. The kernel works to manage all the communications between the computer hardware and software. The kernel is responsible for managing the memory and I/O to memory, cache, the hard driver, and also a few other devices. It is also handle device signals, task scheduling, and other essential duties. The kernel is one of the first components that load into the memory during the boot processes, and it remains active as long as the computer is operational. Kernels are widely used in function and scope, but it does not always greatly affect their operating system capability. For some reasons, there are kernels that, particularly in Unix or Linux administrations, tweak the kernel to the best suit of their requirements.
Assalamualaikum warahmatullahi wabarakatuh. My name is Intan Andirah binti Ahmad. Today, I would like to explain about the comparison in process scheduling between Windows and Linux. Scheduling. The Linux 2.4 schedule is If there are 10 active tasks, scan 10 of them in the list in order to decide which should execute next. This means long scan and long duration under the schedule lock. While Windows NT has always had an scheduler based on pre-sorted thread priority queues, Server 2003 introduced per CPU ready queues. Linux loads balanced queues, Windows does not. Not seen as an issue in perform testing by Microsoft. Applications where it might be an issue are expected to use Affinity. Okay, next I will show you the comparison between Windows and Linux. First, about scheduling priorities. Windows, two scheduling classes, which is real-time fixed priority 6 until 31, dynamic priority 1 to 15. Favor high priorities. Priorities of dynamic threads get boosted on backups. Thread priorities are never lowered, while Linux has three schedule classes. Normal priority 100 to 139, fixed round robin priority 0 to 99, fixed FIFO, which is first in first out priority 0 to 99, favor lower priorities. Priorities of normal threads go up decay as they use CPU. Priorities of interactive threads go down boost. Second, it will be about scheduling details. In Windows, most threads run in variable priorities level. Priority 1 to 15, a newly created thread starts with a base priority. Thread that complete input-output operation experience priority boost, but never higher than 15. A thread priority will never be below base priority. While in Linux, most threads use a dynamic priority policy. Normal class, similar to classic Unix scheduler. A newly created thread starts with a basic priority. Threads that block frequently input-output bound will have their priority gradually increase. Threads that always house their time slice CPU bound will have their priority gradually decrease. Next is about real-time scheduling. In Windows supports static round-robin scheduling policy for threads with priority in real-time range 16 to 31. Threads run for up to 1 quantum. Quantum is reset to full turn-on preemption. Priorities never get boosted. In Linux supports two static priority scheduling policies, which is round-robin and FIFO, first in, first out. FIFO policy lets a thread run to completion. Thread needs to indicate completion by calling the schedule. Round-robin lets threads run for up to 1 time slice. This switches to the next thread with the same static priority. Lastly, about scheduling time slice. In Windows, the thread time slice quantum is 10 to 120 milliseconds. When quanta can vary, has one of two values, recurrent and predictable. While Linux, the thread quantum is 10 to 100 milliseconds, default is 100 milliseconds. Varies across entire range based on priority, which is based on interactivity level, recurrent and predictable. So, that's all about scheduling priorities. Thank you.
Hello and Assalamualaikum. My name is Fatin Nafaka binti Adnan. Today, I would like to explain about process synchronization in Windows and Linux OS. Process synchronizations. Process synchronizations means to share system resources with such a process that simultaneous accesses allocate data to be operated by minimizing the possibility of ecosystem data. It introduced to control problems that arise while multiple process executions. Process synchronizations also maintain data consistency demands mechanism to ensure synchronization of collaboration process. Process synchronizations in Linux. Linux provides several different mechanisms for synchronizations in the kernel. Mutate logs are available in Linux for protecting critical sections within the kernel. Linux also provides pin logs and semaphore as well as reader-writer versions of these two logs for locking in the kernel. On a single processor machine, such as an abandoned system with only one processing core, the spin lock is unsuitable for use and replaced by enabling and disabling the kernel preemption. Process synchronization in Windows. The Windows operating system is a multi-thread kernel that provides support for real-time application and multiple processors. On a multiprocessor system, Windows protects access to global resources using spin locks, although the kernel uses spin locks only to protect shortcode segments. Moreover, on the ground of efficiency, the kernel ensures that the threads will not be restored while holding the spin locks. This is example comparison Linux OS and Windows OS. First, Windows use interrupt to protect access to global resources on unipolar system. Linux disable interrupts to implement short critical sections. Next, Windows provides dispatcher objects which may act as semaphore. Linux just provides semaphore. Next, Windows use spin locks on multiprocessor system. Linux just provides spin locks.
Assalamualaikum and hello everyone. My name is Cik Nur Shakira binti Cik Rifin. Today I will explain about deadlock handling. Okay, a deadlock or hang is caused when two or more threads come into conflict over some resource in such a way that no execution is possible. Okay, there are three deadlock handling strategies. Okay, first prevention, second avoidance, and third is detection and resolution. Okay, prevention. Prevention ensure that four conditions for resource deadlock do not occur simultaneously. Okay, second is avoidance. It analyzes the allocation state to determine whether granting a request, which is resource, might lead to the deadlock later. The third point is detection and resolution. It analyzes the resource state to check whether a deadlock exists. If so, about some processes and allocate the resource to another process. Okay, next I will explain about deadlock handling in Linux operating system. Okay, how to avoid deadlock using coding guideline. First, maintain log order wherever multiple logs are being acquired. Make sure they are all acquired in the same order, otherwise it will lead to ABBA deadlock situation. Okay, second, never require the same log that you are holding. Be aware that the code will be executed in current thread. The function that will be called. So if a log has been acquired in some upstream function, don't require it. Okay, how to detect and solve deadlock. Okay, first, manually inspected to the code to check against the coding guideline above. Okay, second, you can run this trace and check if the process is stuck in wait. Okay, third, if you suspect your application is stuck, you can do this. If the output is D, which is uninterruptible sleep, it could mean there is a deadlock in your code. Okay, 4. Linux kernel has lockdeck, which is an inbuilt feature. Lockdeck can help in pinpointing the line in code causing the deadlock. Okay, 5th, use help green because help green can detect the error that potential deadlock arising from log ordering problem. Moving on to the next point, which is deadlock handling in Windows operating system. Okay, first, make sure that you had the correct most up-to-date video driver installed by going to Device Manager and letting Windows install the newest video driver. Second, did a clean boot by going into Microsoft configuration and disabling all non-Microsoft service and disabling all startup apps. Third, in Microsoft configuration, going to advanced option and setting the number of processors to 8 if you have an 8-core processor, and setting RAM to max. Okay, fourth, in command prompt, as admin running the this command which took 50 minutes, and then rebooting the computer so the change would take effect. 5. In command prompt, as admin running this command which found nothing wrong. 6. Attempted a repair install which for some odd reason that could not actually complete due to error in the wizard on installation media saying that had to restart and try again, but it never had. 7. Doing a custom install which seemed like it had for a while until it deadlocked or froze again. Okay. 8. Doing a clean install as the Microsoft employee assured. 9. Contacting NVIDIA and asking them if there are any report issue with the graphic card and Windows or the driver and the Windows, which assured that there was not. Okay, that's all from me. Thank you.
Hello, my name is Anna. Today I'm going to tell you guys about what is file directory. A directory is a location for storing files on your computer. Directories are found in a hierarchical file system. A directory contains bookkeeping information about files that are, figuratively speaking, beneath them in the hierarchy. Directory is like a file cabinet. Computer manuals often describe directories and file structures in terms of an inverted tree. The files and the directories at any level are contained in the directory above them.
Hi, Assalamualaikum everyone. My name is Intan Shafiza binti Rusli, and I will explain to you guys about the Linux file directory structure. Okay, file directory structure. The directory structure in Linux is unified under the symbol /root file system. File system is physically mounted all directories and are all organized or arranged in hierarchy under a root file system. Okay, basically, Linux files are stored in a storage rooted and hierarchical file system. File system is one of the way on organizing the files on the storage devices, which is for Unix or Linux system. Linux file system have a different structure that user identify or name it as an alien file. It does not use different name structure. As for Linux also, it is a sensitive case for the system. The folder may have files name, which is file, with 3 kinds of file that have a different content. It might use capitalized letter, lowercase, or a different character since it contains different content in each folder or file. This is one of the example of the case sensitivity. You can look at the example here. As you can see from the example just now, it shows that there are 3 kinds of file in the same folder, which is 5 with a different name content. Okay, next, Windows may have C drive and the other drive letter, but as for Linux, both are gone. It doesn't have C drive or any other drive letters. It uses different directories and such as /A and cryptic sounding directories that are mostly contains 3 letters. You can look at the example given. It shows the file or folder in Linux. As we all know, Windows and Linux has a different directories. So this is the example of the directories that have in Linux operating system. Okay, next, this is the example of typical file system for Linux. As you can see, it is a hierarchical type arrangement. And as you can see also, it shows that it is a rooted system which is from one folder to another folder. Moving on to another point, which is I will explain to you and show you the differences of characteristic between Windows and Linux. As you can see from the given figure, it shows a few characteristics for Windows and Linux. The characteristics are file system, references root of each partition point, file extension, case sensitive, kernel type, and developer. I think that's all for me. Thank you.
Hi, Assalamualaikum. My name is Nur Atira binti Fazilah. Now, I'm going to introduce you guys about the file directory of Windows. As users use Windows or any OS on their PC, there must be a lot of files or folders that they might be want to use. So, file and directory was created to help the user. As Microsoft Windows comes with Windows Explorer. Now, let us see the interface of the Windows Explorer. You can imagine that each hard drive is like filing cabinet in an office. At the Windows Explorer, we have devices and drive. We have C drive, D drive, and E drive. On top of this are the folders where user might want to save their document, downloads, movies, and so on. Next, if user want to naming or renaming a file, they cannot name it with the same name with another file on the same folder. This is because the Windows file system is not case sensitive, so it treats this name as the same file. In this case, user need to rename the file with another name. Windows also tell the user what device or removable drive that connected to the PC, as we see here. Now, I'm connecting my phone to this PC. There is a folder for my phone there. In order to make Windows more user-friendly, Windows also let the user manipulate or modify the open files. They let the user to delete, rename, and remove, and so on the files. On Windows, applications allow exclusive access to files compared to the Linux. For example, users are watching a video on VLC, and at the same time, users are trying to delete the video from files. User will see an error message that user need to stop watching the file in the VLC before delete it, rename, or do anything else in it. In a nutshell, I can say that Windows and Linux has more or less differences on their file directory. In this, just to make this post OS more user-friendly and easier for the user to understand this OS interface. It makes those OS well organized. I think that's all from me. Thank you.